Hello, this lesson is on introducing slope-intercept form of an equation. And just some vocabulary terms getting into slope-intercept form. Slope, we've learned, is the change in y over the change in x of a line. Another way of thinking about this is rise over run, or like I said, the change in y values or coordinates over the change in x coordinates or values. So slope is the steepness of a line, and the rise over the run, or the change in y over the change in x of a line on a graph. The intercepts, if you think of a coordinate grid, you have a y-axis and you have an x-axis. And an intercept means it's crossing one of those. It's intercepting one of the axes. And specifically in this lesson, we're going to be talking about y-intercepts. So that means we are looking at where a point is crossing our y-axis. So a y-intercept means that point on that line is somewhere on this y-axis. And then an equation just represents a line. So if this is our line, so if here is our line, this line is an equation. We can write an equation for this line. The slope is the steepness, so the change in y over the change in x. So how steep that line is, and our y-intercept, that means that's where this line is crossing our y-axis. So looking at slope-intercept form is a type of, or a form of writing an equation where you can easily see what the slope is and what the y-intercept is of that equation. So slope-intercept form is always going to be written as y equals mx plus b, and m is the slope. That's the number that represents our slope, and b is our y-intercept. So that means that's where my line is crossing the y-axis. Note that y here is not the y-intercept. They use b to represent that y-intercept, or where it's crossing the y-axis. And then this x and y in the equation, that x and y just represents some coordinate that's on that line that can be graphed. So when you're using it in an equation, you're going to leave it as the y and the x's in there, but there will be a number in place of m and a number in place of b. So for example, y equals 1/3 x plus 9. This example would mean that this equation has a slope of 1/3. So a rise of 1 and a run of 3, or a change in y values of 1 and a change in x values of 3. And then this one would have a y-intercept of 9, meaning that it is crossing our y-axis at the point 9. So thinking of where that would be on the graph, if you look on your coordinate grid, let's say this is my coordinate grid. If I want to see where it's crossing at 9, here's 0, 0. The y-axis is its vertical axis, so this line would cross at 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This line is going to go through that point. So let's look at some equations in slope-intercept form. On this first equation, we have y equals 3x plus 4. We want to identify the slope. Again, slope, whoops, that's too many lines there. Slope is m. The intercept, which we're referring to our y-intercept, that's in place of b. So if you think of our equation for slope-intercept form, we have y equals mx plus b. In this first equation, y equals mx, or y equals 3x plus 4, the number in place of slope is 3. So we would say that our slope, or m, is 3. And since it's a slope, think of it as 3 over 1. So a rise of 3, up and down, counting 3, a run of 1. And our y-intercept for this one, or in this case, in our equation, it represents b. Our y-intercept is crossing our y-axis at the coordinate 4 on our y-axis. Our second equation, y equals a negative 1/2 x minus 6. The slope for this one, it's the number that's multiplied by x. So right here I see a minus 1/2. Make sure you look for negatives. So the slope of this line is a negative 1/2. And the y-intercept, or we note that with b, the y-intercept is 6, but it's actually a minus 6. Always look in front of that line. This is actually a minus 6. So on our coordinate grid, this is crossing my y-axis at a negative 6. Always look for that subtraction in front that notes that this is a negative number. Last example, y equals 7/6 x plus 2. Thinking of where the slope is, again, slope is the number multiplied by x. We note that with an m. M equals 7/6. So the slope of this line is 7/6. It's got a change in the y values of 7 and a change in the x values of 6. Or think of it as rise over run. A rise of 7, a run of 6. And then our y-intercept, again, that's noted with b. The y-intercept, or where it's crossing our y-axis, it's a positive 2. So it's crossing our y-axis at a positive 2. And then one last example to get into the main part of this lesson. If you're given an equation, so in this example, 2x plus 5y equals 15, if we want to rewrite this in slope-intercept form, that means we want our equation to look like y equals mx plus b, where m is a number representing the slope and b is a number representing the y-intercept, and our equation will still have y and x. You can see that in our equation we still have x and y here, but we want to solve this so that y is by itself. So we actually are going to use inverse operations. Just like what we use to solve equations, we want to do the opposite of what's there to first get our y term. My y term is 5y. I want to get 5y by itself. So I need to do something with this 2x. Since 2x is positive, to take it off of that side, we would need to subtract 2x. And if we subtract 2x on one side of our equation, we have to subtract 2x on the other. So then 2x minus 2x, they're opposites. They cancel each other out, and we still have a positive 5y. So 5y is equal to 15 minus 2x. Note, I didn't subtract 15 minus 2. These are not like terms, so I can't actually subtract 15 minus 2x to get 13x. I would need to leave it as 15 minus 2. Last step is to get y by itself, so we want to divide by 5. And when you're rearranging an equation, think of it as dividing every single term by 5. Because you can group it like this and divide by 5. But it's easier to remember what to do if you treat it as when you're dividing an equation by something, divide everything by 5. It's like using the distributive property backwards. So 5 divided by 5 cancels out, and you're left with y equals 15 divided by 5 is 3. And a minus 2 divided by 5, leave that as a fraction, so a negative 2/5 x. And we're almost done. We have y by itself, but we want to write it in slope-intercept form. That means we want our x term to come first, so you can reorder these two terms. Just make sure that this one is still subtracted. So y equals a minus 2/5 x, and then a positive 3, so plus 3. And now our equation is in slope-intercept form. So really, you're just solving to get y by itself using inverse operations. And make sure your slope, so the number multiplied by x, negative 2/5, this is still a fraction.